From woolly mammoths to saber-toothed tigers, there have been many theories about bringing extinct species back to life. And while the concept might seem far-fetched, scientists are actually getting pretty close. One creature that has captured the public's imagination is the Tyrannosaurus rex. What if we could bring back one of the most fearsome predators of all time? Now, before we get started, we want to say this is a purely hypothetical discussion based on current scientific understanding. There's no evidence to suggest that a T-Rex could be frozen for millions of years and still exist. In fact, it goes against everything we know about biology, physics, and geology. A massive asteroid impact near present-day Chicxulub, Mexico, unleashed wildfires, blocked out the sun, and triggered mass extinction across the globe. This is a key factor when considering whether a T-Rex could have been frozen and preserved. This is known as the Cretaceous-Paleogene (KPG) extinction event. But for fun and for the sake of exploring the boundaries of what's possible, let's pretend that anything could happen. The image is almost irresistible. A team of scientists trekking across a desolate Arctic landscape stumbles upon an eerie silhouette, half buried in ancient ice. In some cases, animals like woolly mammoths and prehistoric horses have been found in the Siberian permafrost, with skin, hair, internal organs, and even stomach contents intact. There were no glaciers, no polar ice caps, and no environment cold enough to freeze and preserve a dinosaur. Even the high-latitude regions where some dinosaurs lived were relatively temperate. These discoveries have thrilled scientists because they offer rare chances to study ancient DNA and biology. As the snow is brushed away, the unmistakable shape of a Tyrannosaurus rex, the apex predator of the late Cretaceous, is revealed, perfectly preserved in a frozen tomb. Its teeth are still sharp, skin tough and leathery, and DNA intact. Could such a thing be possible? Could a T-Rex, one of the most fearsome creatures to ever walk the earth, have somehow survived the ravages of time, frozen in ice for millions of years? This question may sound like science fiction, but it opens a fascinating gateway into science fact, how preservation works, what the fossil record tells us, and where the lines between imagination and scientific possibility begin to blur. The oldest preserved biological tissues found in permafrost are no older than 1 million years, and even that is exceptionally rare. Ice simply doesn't last for 66 million years due to the Earth's natural geologic cycles. The T-Rex timeline. When did they live? Before diving into the possibility of a frozen T-Rex, it's important to understand the timeline. Decomposition still occurs due to microbial activity, and bones on the ocean floor are typically colonized and broken down within years to decades. Tyrannosaurus rex lived approximately 68 to 66 million years ago. In the final chapter of the Mesozoic era, known as the Late Cretaceous period, they roamed parts of what is now North America, preying on large herbivores like Triceratops and Edmontosaurus. Let's explore these possibilities. However, about 66 million years ago, the reign of the dinosaurs came to a catastrophic end. Most importantly for our question, the Ice Age, when large portions of the Earth were covered by glaciers, didn't begin until about 2.4 million years ago, long after dinosaurs had gone extinct. Could a T-Rex be preserved in ice? To answer this, let's look at what conditions are required to preserve biological material for long periods. She found what looked like blood vessels, collagen, and possible red blood cells. The discovery shook the scientific community and ignited hope that some biological material might survive fossilization. As the bones are buried under sediment, groundwater carrying minerals seeps into the bone pores. After about 1.5 million years, even the best preserved DNA would be broken into tiny, unreadable fragments. Over time, the organic material decays, and the minerals fill in the spaces, turning the bones to rock. It's an incredible preservation method, but it doesn't preserve DNA or soft tissue. 1. Cryopreservation and the natural freezer effect. Freezing is one of the most effective natural methods for preserving organic material. But these creatures lived during the Pleistocene epoch, which began just 2.4 million years ago, not 66 million years ago. The Earth during the Cretaceous period was far warmer than it is today. And don't forget to subscribe for more videos like this. Thanks for watching. The timeline, environmental conditions, and decay processes make it effectively impossible for a Tyrannosaurus rex to be preserved in ice. Science thrives on what-if questions. They push the boundaries of knowledge, fuel imagination, and drive new discoveries. While you won't find a real T-Rex emerging from a block of ice, you can discover the incredible story of how life evolved, how creatures adapted and disappeared, and how in some ways, the age of the dinosaurs still echoes in every bird's call. So for a T-Rex to have been frozen, it would have required a sudden and extreme drop in temperature, rapid burial in ice, complete isolation from oxygen and microbes. Such conditions simply didn't exist during the time of the dinosaurs. What about deep underground or underwater freezing? Some might argue that perhaps a T-Rex could have become trapped in a glacier, a cave, or a deep underwater environment with unique preservation conditions. Permafrost and glaciers. Glaciers and permafrost are Earth's natural freezers, and they have yielded some astonishing finds, like the 5,300-year-old Tsi, the Iceman in the Alps, or the nearly intact baby mammoth Luba from Siberia. But again, these finds are all tens of thousands of years old, not millions. Tectonic activity, erosion, and changes in the Earth's orbit all contribute to major shifts in climate over millions of years, and any glacial formation would have long since disappeared or transformed. 3. Deep sea freezing or anaerobic environments. What about the bottom of the ocean or in oxygen-deprived environments like tar pits or peat bogs? The ocean floor is cold and dark, but it's not a freezer. Anaerobic environments like bogs and tar pits do preserve some soft tissue, but again, these examples, such as the La Brea tar pits in California, only go back tens of thousands of years. Even if a T-Rex carcass somehow ended up in one of these environments, the chances of soft tissue or DNA surviving millions of years are essentially zero. What science tells us about dinosaur fossils when paleontologists find dinosaur fossils? They aren't finding frozen or preserved bodies, they're finding mineralized bones, turned to stone over millions of years. This is called permineralization. However, there have been some exciting discoveries in recent decades that might offer a tiny glimmer of hope. Could dinosaur DNA still be found? In 2005, Dr. Mary Schweitzer, a paleontologist from North Carolina State University, made a groundbreaking discovery: soft tissue fragments inside the fossilized bone of a T-Rex. Subsequent studies confirmed that these soft tissues were real and not contamination. But the big question remained: could any DNA survive? The half-life of DNA is incredibly fragile. A 2012 study calculated that DNA has a half-life of about 521 years under ideal conditions. So even if soft tissue exists in some fossils, retrieving intact DNA from a 66-million-year-old T-Rex is currently beyond the limits of science. That means no cloned dinosaurs, no Jurassic Park-style resurrections, at least. Not from dinosaur DNA. So, could a frozen T-Rex still exist? From a scientific standpoint, the answer is no, not in the literal sense. But that doesn't mean the question isn't worth asking. The T-Rex may be gone, but its story is far from frozen. What do you think? Is it possible for a T-Rex to be frozen for millions of years? Let us know your thoughts in the comments below.